Okay, so this is part 2 in the review. We're going to cover 9.3 and 9.5, which is, if you remember, geometric sequences and series. So we have a sequence. Let's check it out. Let's go 1, 2, 4, 8, 16. You'll notice it's not arithmetic because you're adding 1, then you're adding 2, then you're adding 4, then you're adding 8, so it's not a common difference. What you will notice, though, is that the pattern happens to be that it's multiplying by 2 each time. Times 2, times 2, over and over and over and over again. So if I want to find some number term in this sequence, let's say the 8th term, I've got 1, 2, 3, 4, 5 terms here. I could just keep going, but let's say I got to know the 8th term. This is another flower pot that you need to know. All right, let me put my letters in here. The amount of any term is equal to the first term times the common ratio risen to the n minus 1 power. So common ratio, that's this guy. Whatever you're multiplying by each time is your common ratio, r. So if I want to know the 8th term in this sequence, was what I said, so a8 equals the first term, which was 1, times my common ratio, which is 2, to the n, which is 8, minus 1, which would make 7th power. I can just come over here, 2 to the 7th power is 128. 128 times 1 is 128. That would be the 8th term in this sequence. Now, just like the other time, it's pretty much that simple, but I may also ask you to find like a missing blank. So let's go 12 blank 3. Now, instead of going 12 plus 3 and divided by 2, just finding the average like you did back when with arithmetic, this one's done slightly different. You're going to take this multiplied by this, because we're multiplying up here, not adding, and then take the square root of that. So it looks like this, xy, where x is the first term that you're trying to find and y is the second term. So 12 times 3 is 36, and if you take the square root of 36, you get 6. And so you can see if I plug 6 in here, 12 divided by 2 is 6, and 6 divided by 2 is 3. So you see it fits the pattern. Here's where I want you to look at this. When you're dividing, I want you to write your common ratio not as divide by 2. That's the wrong way. What you want to do is express this division in terms of a fraction. So really, the common ratio here would be 1/2. We're multiplying by 1/2. And if you see 12 times 1/2 is 6. And this is because when we get to series here in a few minutes, it'll be important to have it expressed as a fraction. So remember that. So moving right along, not going to waste any time. Remember, flower pot this bad boy, and common ratio is multiplying or dividing by the same number each time. New page, geoseries. Just like arithmetic series, it's the same thing, only now we're adding. And sometimes it will be this simple. 1, 2, 3, 4, 5 terms. Now, the difference is here, your formula is a little different, and I'm not going to make you remember this guy. It'll be given to you if you have to do this. Because it is kind of a bear. So I got to draw some stuff. The sum of any number of terms is the first term multiplied by 1 minus r to the nth power over 1 minus r. That's pretty difficult to memorize, so instead I would put it in sigma notation, where we've got n equals 1. There are 1, 2, 3, 4, 5 terms here, and our explicit formula can be found by plugging this into our flower pot. So let's do that. an equals the first term times our common ratio, which is 2 to the n minus 1. Now, remember what I told you to do here is, we know this is 16. So what you need to do here is solve. So we have to get the n minus 1 by itself. So we're going to divide each side by 1. Well, that was easy. And so the 1's cancel out, and we have 16 equals 2 to the n minus 1. Now, you could do all that to find the number of terms, but we know the number of terms. So let's just make our explicit formula 1 times 2 to the n minus 1. Now, when you plug this into a calculator, you have to be careful. So I want to show you alpha f2 summation. We've got first term, and there are 1, 2, 3, 4, 5 terms, and we are going to plug in the explicit formula 1 times 2 to the parentheses x minus 1 in parentheses. Good to go. If you solve this, you can see 31. 1 plus 2 plus 4 plus 8 plus 16 is 31. Awesome. But as you likely know, it's not always that easy. So let's look at this. I'm going to take the same series we have, but I'm going to make it end at 121 or 128 instead. And so now the problem is we don't know how many terms there are. So we don't know what the upper limit of our sigma notation would be. And so we have to find that. So we're going to set it up just the same way though. Sigma notation, n equals 1. We have to find this term here, and then we also have to find the explicit formula. So here is where we do have to do some solving. So let's plug this back into our flower pot. We know the last term is equal to the first term times our common ratio, as you can see, multiply by 2, multiply by 2, multiply by 2, to the n minus 1. N minus 1. That's an n minus 1. So now we have to work on getting this by itself. So we divide each side by 1. It won't always be that nice and pretty like that, but in this example it is. So now we have 128 equals 2 to the n minus 1. So now we have to figure out 2 to the what equals 128. Well, let's check this out. Go to y equals and put 2 to the x up here and hit second table. So now we got to find 128. Oh, dang, right here. So we know that 2 to the 7th power equals 128. Well, how can I make this equal 7? Oh, well, for in order that happen, this would have to be 8, right? Because 8 minus 1 is 7. So now I have this number right here, which is 8. Oh, and before I did all this work, check it out. Right here, there's my explicit formula. So put it right here, and we are in business. And so you could do this. But now we're going to change this guy over here from a 5 to an 8. And there you go. 255 would be the answer if I added all those together. 255. Now it's at this point in time, I want to show the people who don't have this operating system how to enter this in there. Remember, it's like the second stat math 5, second stat ops 5, and then it may show up like this for you if you had the new one, but you guys don't have that. So I'm going to show you what it should look like. After you see sum and then sequence, you write your explicit formula, which for us, I went way too far. For us was 1 times 2 to the x minus 1. and then you write your variable, which is x, and then you write your lower limit, which was 1, and then you write your upper limit, which was 8, and then behold, 255. So here's what it should look like for the old operating system people. Here's what it should look like for the new operating system people. Those who don't have a graphing calculator, then you're just going to have to manually do all the adding. So you would have to find, we have 1, 2, 3, 4. You'd have to find the 5th term, the 6th term, the 7th term, and then add all those together. So that takes a little longer. So it's probably a good idea to talk your parents into getting you one of these things. All right, one last little example to show you. What if we have a series that goes on forever and ever and ever and ever and ever? So what if I do that same thing? Oh, but it's a series. Oh man, now it's infinite. Now all that work we just did can't do anymore. So this is when I said it's important to write your ratio as a fraction if you're doing division, because I'm just going to reverse this on and on and on forever. If you look, this is multiplying by 2. R equals 2. If you look, this is dividing by 2, so R equals 1/2. This is important because of this rule I'm going to tell you. If the absolute value of R, so that means it doesn't really matter if it's negative or not, is less than, we'll do greater than first. If it's greater than 1, like in this case, then it is diverging. It is going to diverge from this number forever. And if it's diverging, that means there's no sum. It's impossible to add everything up together because you never know where it's going to end. If you have this exact same thing, only it's not greater than 1, it's less than 1, well, then that means it's going to be converging. So we're just going to keep getting closer and closer and closer to some number. And that means it will have a partial sum. And to find that, there's one more formula which you should probably be familiar with. I don't want to necessarily say you have to flower pot it, but you're going to want to be able to calculate this partial sum. This one, no sum, diverging. This one, 1/2 is less than 1, so it's converging, so there's a partial sum. You have to do this. S, which is a partial sum, is the first term divided by 1 minus your common ratio. So it's pretty easy. We know 1, our first term is 8, and we know our common ratio to be 1/2. 1 minus 1/2 is 1/2. 8 divided by 1/2 is 16. The partial sum of this is 16. That's what we're converging to, where if you add everything up together, because you can see it'd be 1/2, then a 4th, then an 8th, then a 16th, and it keep going on and on and on and on. It would never hit 0, but we would just get a partial sum of 16. So keep that in mind. If you have any questions, shoot me a Canvas message, but we'll talk some more tomorrow. Goodbye.